Alrighty. So I'm gonna go ahead and skip down to this one because this one is obviously a little bit more unique between these two. I think you can figure out based on the first question there and just trial and error figuring out which one was the longest chain by counting each individual single one over there. So for this one is interesting because it's a circle. And for the circle ones, it's it's really interesting because they're always going to have one carbon attached to two hydrogens connected to other two carbons. So the definition for a cycloalkane or a like a circle hydrocarbon, right, is that each carbon is connected to two hydrogens here and two carbons there. And every single one is going to be that way. So the chemical formula, like we've discussed in class, is going to be Cn. N could be whatever number. And then the hydrogen is going to be N or 2 times N because you're just doubling it per carbon because there's only 2 added to each one. All right. So in order to name these, all you have to do is count the amount of carbons that are there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 carbons there. So we know that with 9 carbons, it's going to be nonane, right? Because that's the prefix that we give it. But because it is a circle in nature, right? It has a different chemical formula than everything else. We have to be able to disclose that. So all we're going to do is get ready for this, the word cyclo in front of it. So if you had nonane, just regular nonane, it would just be 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons all connected together. The ends are going to have 3 hydrogens on the ends, and every single one in the middle is only going to have 2 hydrogens, right? So the chemical formula is going to be different. But this one, this one, that the chemical formula would be like C9H, oh, sorry, 20, because over here I know it's going to be CnH2n plus 2 because you have 3 carbons on the end. So that's 1, 1. That's where we get plus 2. This one, it's going to be the chemical formula for this one is C9H18. And so the chemical formula is different. The name has to be different, right? And so this one, if it was just all straight in a row like that, none of like they don't have 2 carbons connected to each other and no like 2 hydrogens connected to each other, it's just going to be plain no name. And so that's kind of the difference between there. I think you guys picked up on that, but that's something that I just think is good to know. So we're going to clear all of that. And we're probably going to move on to this bottom one. I need to scroll down. Alrighty. So this one is the one that I kind of got tripped up here on number 5. You have to be really careful once again when you're counting for the longest chain. So originally what I did is I went 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then I was like, okay, let's do 1, 2, 3, 4, 5, 6, 7. Now I still have 8 going that way. But actually, what you're going to do is you're going to start down here because you've got 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So the longest chain of carbons in this one is going to be 9. You got to be careful. Once again, take your time, count every single chain that you see, remember that like which one was your longest and try to just keep going. And it's very hard. So don't beat yourself up about this because missing one is honestly, you know, trivial. It doesn't matter. This is towards the end of the semester, so don't panic about it. So we have 9 here. So the base name we're going to put here at the end is going to be no name. And I know this one's kind of long, so I'm probably going to erase that later, but or write off over here more, but that's going to be that. So now that we know what the base name is, we know what the longest continuous chain, what's the next step? Well, the next step, what I'm going to say, is to identify all the branches and give them names. Okay? So this branch right here, I see, looks the same as this branch over here. This branch has 2 carbons in it. So instead of it being methane, which is just CH3, it's going to be, or yes, it's going to be ethyl, which is CH3 for a branch. This one, because it's a branch, it won't be ethane, it'll be ethyl. So I'm going to label them ethyl over here and ethyl over here. And if you want, instead of maybe like make like different shapes, so like make a square, a block around the longest chain, and then a circle around all the branches so that you know. And so let's like say, oh, this one's a different type of branch because it only has 1 carbon. I'm going to make a triangle around that. And this one, I kind of gave you the answer earlier, but since there's only 1 carbon, it's going to be methyl. And methyl. Now the difficulty here is figuring out, where do we start to count? This is the longest chain. So if we count 1, 2, 3, 4, we've got 4, 4 right there. 2 branches on 4. If we count here, 1, 2, 3, 4, we got 2 branches on 4 here. So honestly, this one, because it's symmetrical in nature, it doesn't really matter where you count. You could start from this side or you could start from this side. But these, remember, these ones on the side here, those are not part of the longest continuous chain. Those are the branches that we've labeled. So I'm just going to go ahead and label this one 1, 2, 3. This one's 4 up here. And if you'll notice, whenever you have 2 branches coming off a single carbon connected to the longest continuous chain, there's only 1 carbon there. There's only 1 carbon here. Does that make sense? Because there's going to be 4. This is what Mrs. Bosch would call a quadruple junction, is whenever carbons connected to 4 more carbons. So that's 4. This one would be 5. And this branch, or this coordinate, would be 6. And so we have 2 ethyls and we have 2 methyls. So I'm going to make my list. There's 4 methyl over here to the side, and there's 4 ethyl. Sorry, there's not 4 branches of ethyl. It's 4-methyl, 4-ethyl, because those are the coordinates of to where these branches are on the chain. So we have an ethyl here, 2 carbon, a methyl here, 1 carbon. Then I go over here to 6, and there's also a methyl and an ethyl. So I'm going to say 6-methyl, 6-methyl. The notation really matters, believe it or not, but I don't think she's going to count off points if you don't put the dash there. As long as you have the commas and the right amount of branches and numbers match up, okay? So we have 6-ethyl as well. So we have 1, 2, 3, 4. So there should be 4 branches here, right? 1, 2, 3, 4. Yep, we got 4 branches. But that also means that there needs to be 4 numbers in our name. And what do? We start in alphabetical order because they want it to be in alphabetical order and the smallest numbers that it could possibly be. So for consistency. So we're going to start with ethyl here. So what we're going to do, I'm going to say, I'm probably going to bring it up here, 4, 6. There's 2 ethyls. And what do we know whenever there's 2 ethyls? You got to put the prefix di. If there was 3 ethyls, it would be tri. 4 ethyls, it would be quadrethyl. Anyway, we're gonna put a dash here and then di. Sorry, I was about to write ethyl there, but I just explained that there's diethyls because there's two numbers. Whenever you have a comma, there better, if you have two numbers here, there better be a prefix for di there, you know? If there's three numbers here, there better be a prefix for tri connected to your ethyl, methyl, propyl, whatever branch that it is. All right. And then we're going to do another dash because we have another set of branches. 4-methyl and 6-methyl, just like this one. So it's also 2. So we're also going to put di in front of the methyls. 4,6 dash methyl. And that is going to be the correct answer for that one. And it's 4,6 diethyl, 4,6 dimethyl. I wrote methyl there. You see how I wrote methyl there? So remember to double check your work and rewrite whatever you can. I was just trying to squeeze it in there. But that's dimethyl nonate. All right, I'm going to clear all of that and we're going to move up to drawing drawing them. So what do I see here? The first thing that I want you to think about, to notice whenever you are drawing condensed structures for names that you're given, is immediately go to the end of the name. How many carbon do I need to have? And I think the easiest way is to just make it a straight line. All right, so we've got C, C, C. Oh, and this means 9, right? This means 9. So we're going to have 9 carbons. Sorry about that. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And like I described to you before, I don't see a cyclo in this name. So that means that the ends of this compound are going to end with CH3 because they're only going to be connected to one other carbon because they're at the end. They have an end, unlike the cycloalkanes, right? So then I'm going to connect it to this one, and I'm just going to kind of leave this space open here for me to interpret because I see on the second carbon in this chain, you can start from here, or you could start from here. You could say this is the second carbon, or you could say this is the second carbon. I'm going to say this is the second carbon. Off of the second carbon here, this is connected to methyl. I think I covered up the L of there, but it's methyl. And so I see its second one is going to have methyl. I'm going to make it come up here. And this is a branch. This is a branch off of the second. This is the coordinate for methyl. So methyl is going to be that CH3. That's methyl because that's a branch and it comes up off of it. Next thing that I see is a branch on 3 for methyl. And I also see a branch on 3 for ethyl. So this is one. Don't be tempted to just put H's in because some of them you will have quadruple junctions where you don't need an H at all because the carbon is going to be connected to all 4 carbon, just like how it was down here where you can see that the carbon is connected to all 4 carbon. It has no room for hydrogen. So make sure that, I mean, you could put H's in there, but you're going to have to erase them later if there is a quadruple junction. So on number 3 here, I see 2 number 3s. That signifies to me, oh, shoot, this is a quadruple junction. And so this was my second one. That means this has got to be my third one. I'm going to put methyl up here. And methyl is going to be the one with 1 carbon. And then I'm going to put ethyl down here, which is going to be the one with 2 carbons. And how we write that is just CH2 connected to CH3. And that's ethyl. All right. So this one, I'm going to go ahead and connect. This one is going to have 2 carbons, or 2 hydrogens, sorry, 2 hydrogens connected to that carbon because it's connected to 2 hydrogens along with connected to carbon and to carbon. So it fulfills that rule of 4. This one is going to have no hydrogens because it's already fulfilling that rule of 4. It's connected to another carbon, to another carbon, to another carbon, to another carbon. So we don't have to worry about that. Make sure that whenever you have just a quadruple junction, that there's no hydrogen. But whenever you have a triple junction like here, we see how this one is connected to 1 carbon, 2 carbon, and 3 carbon, not just 2 carbon. that means that you're gonna have, fix my mistake here, right here, because I messed it up. You're only gonna have one H here because it's connected to 3 carbons. See, we fixed that mistake right there. You learn from your mistakes. So good thing that I checked over that, because that one is only going to be 1 H. Now we go on to this next one. This is going to be 4, where I see 4 here too. Let me highlight this one just to make sure. Sorry, talking makes your throat dry so much. Okay, so 4, we also have another methyl because that's what's connected. These are all going to be connected to this word. This one's going to be connected to this one. This type of branch, these are all connected to this type of branch. So on 4, it's going to be another methyl. Oop. There we go. And then this one, it's only going to be a triple junction, sorry, not a quadruple junction. So I can just put 1 H because it's going to be connected to 3 carbon along with 1 H. This one is only going to be connected to 2 carbons, so it needs 2 H's. And 2 H's, and 2 H's, and 2 H's. And that is going to be the finished product for the drawing. I think that the drawing is a little bit easier than the naming, but that is my personal opinion. We're gonna skip down. We're actually gonna do the second one here because it has propyl in it, and we haven't worked with one that has propyl in it. So I'm gonna do the second one here for you. First thing that you do, what I want you to notice is, remember the base of how many carbon there's going to be. Octane, there's going to be 8 carbons. So 1, 2, 3, 7, 8. Okay. Now, remember the end's always going to be CH3, unless it's a cycloalkane. But if it's a cycloalkane, you'll draw it in a circle, right? And every carbon is going to have 2 carbons and 2 hydrogens connected to it if it's a circle. All right, but this is a line, so the ends are always going to have CH3 at the end. Now you could start your counting. You could go 1, 2, or you could go 1, 2, 3, 4, 5. I'm going to start from the left just because it makes it simpler. So this one is going to be my 2, and I am going to draw a branch of methyl because this 2 is connected to methyl. This 5 is connected to propyl, and these are the types of branches that we're going to be connecting to the continuous chain. That is the octane. It's a lot of vocabulary, but if you practice this yourself, I would try this one yourself by yourself. You'll be able to get it, I promise. So methyl here, we've got a methyl on 2, and methyl is CH3. That's the type of branch. And now I think, it's connected to 3 carbons. It needs 1 hydrogen. This one is 3, and so it's not going to be connected to, it's not going to have any branches on it, so it's going to be 2. This one is 4, and this one is not quite yet to 5, so this one is also going to have 2. And then this one right here is number 5, and it's going to have another branch off of it, but this branch is going to be different. It's different from all the other branches that we've done so far. And propyl is going to be a branch with 3 carbons in it. So it's going to go 1 carbon, 2 carbon, 3 carbon. And at the 3rd carbon, at the end, it's going to be CH3. And then on this one, it's going to be 2. And on this one, it's going to be 2. But this carbon right here is connected to 1, 2, 3, and then a hydrogen to fulfill that rule of 4. So then we move on to the next carbon. This one's only connected to 2, so it needs 2 hydrogen. This one is connected to 2, so it needs 2 hydrogen as well. And that is the finished product for that one. Alrighty, we're gonna stop here, and you can do the last one there.